Good morning, everyone, and welcome to the data structure theory session. Till now, in a linear data structure, we had gone through arrays, stacks, queues, and right now we're going through the linked list. And linked list, in linked list also, we have seen, we have understood how linked list works, its operations, and we have also gone through few operations on a singly linked list as well as circular linked list. So from today onwards, we want to go for a doubly linked list now. We'll first understand how doubly linked list look like, and how we can create doubly linked list, and then we'll go through few operations on doubly linked list, insert and delete operations. Once we complete doubly linked list, we'll also see doubly circular, and then at the end we'll see few applications of linked list. Right? So let's start doubly linked list now. As its name suggests, doubly linked. So it has two links. So each node in a doubly linked list will have two links, one for the previous node and the second for the next node, right? Now, when you say previous and the last, previous and the next node, if you consider your first node, then it does not have anything before that. So previous link of first node will be null. And when you're talking about last node, there is nothing after that. So the next link of last node will be null. Other than this, on every places, you will find proper previous and next links for the previous and next node. Okay. So what is your node? Every node in a doubly linked list will have three portions. One minimum three portions. Okay. One to store your data. Now, if you have multiple data, you can have multiple partitions here. So a node in a doubly linked list will have at least three partition. At max, as many partitions you want, you can create in a node and you can store your data. So there will be data part, then there will be previous pointer, and there will be next pointer in your node. Okay. So that's your node. How to create it? Create a structure, have three members, one data member, and then there are two pointer members, and you will have your node. Now, whenever you require a node in algorithm, we'll write avail. We'll take new node from avail and increase avail. But in a program, what we'll do is we'll go for malloc statement, right? So that we will see in the lab session when we create any linked list. So this is what the doubly linked list look like. And in a doubly linked list, whenever you have a node, your node will have previous pointer, next pointer, and a data part. So with this understanding, let us have a look at how this doubly linked list is beneficial, or what extra care we need to take. So when we are talking about doubly linked list, traversal will be very much easier in back and forth both the directions, because in a singly linked list we were able to traverse in a forward direction only. We were not able to go backward. Now if you want to go in a backward direction, then in a circular manner we will traverse and come back to the previous node. Whereas here we have previous link directly. So traversal in any direction will be very much easier in the doubly linked list. That's the advantage, we can say. Now, as long as you can directly go backward, it reduces time to execute any of the operations on a data. whenever you want, wherever you want, you can reach quickly. So it reduces time also. Now, because of this reason, you have a flexibility to traverse back and forth both. So it's kind of a normal list where your data need not to be in a same location in your memory. So and doubly linked list can be used to represent any other data structure also, right? Doubly linked list you can use to create a stack, to create a queue. And we will also see we can use this doubly linked list kind of structure to create a tree also, and a graph. So graphs can be represented using doubly linked list also. Binary tree is nothing. Binary tree node is nothing but a doubly linked list node. And when we are talking about tree, so it's kind of a hierarchical structure. Tree can be easily represented using doubly linked list, right? So these are few advantages. And definitely when we go for some newer thing, it might have few disadvantage also. Now each node in a doubly linked list requires extra space to store the previous node pointer. So it requires extra space, and while manipulating this list, we need to take extra care of maintaining both the direction pointers, right? So that's the extra work we need to do. We need to we need to maintain previous pointer also. So these are few minor disadvantages, but because of this reason, we have a larger benefits. So we can bear those 2 points. So let's have a look at now doubly linked list operations. We know how doubly linked list looks. We know how doubly linked list works, right? So let us go and insert few nodes in a doubly linked list. So we want to go for multiple insert operations on a doubly linked list. We'll go for insert first, insert last, insert at position, insert before, insert after. And if you carefully learn all these insert operations, then you will be able to complete insert sorted also. So I'm not going to do that here. Right? We have seen insert sorted in the singly linked list already. So same function, same functionality, same process, just you need to maintain the previous pointer extra. That's it. So let's go and have a look at the insert first algorithm, how insert first works. Now, as you already know, we have number of cases. So here also we are gonna consider those cases. What if your linked list is already empty, right? What if your linked list is already empty? And in the other case, what if you have some nodes? Well, in both these cases, we can say if linked list is empty, then my start will be pointing to null. And if I do have some nodes, then my start will be pointing to a first node of doubly linked list, remember. So now this is a doubly linked list node. First node previous pointer will be null, and the next pointer will be pointing to the next node, right? So like this way, we will be having doubly linked list. Now in the doubly linked list, every node has a previous pointer. So previous pointer is just pointing to the previous node, and the last node next pointer will be null. And it might have few data, let's say 2, 4, and 6. So this is how doubly linked list look like, and we can represent doubly linked list with this diagram. So this is what we have in case 2. Now what we want to do is we want to insert a new node at a first place. So definitely we require new node first. So let us have new node n. And in both the cases, we require new node n. So we take a new node from avail and we update avail. In program, we'll go for malloc statement. Now, once we have a new node, what we do is we save the data, given data, and well, we are going to save it in the new node data. So if user has given, let's say 1, then we will store that 1 in new node data part. So n points to data equals to new value given. So we have that data also. Now we need to take care of two cases, and then we'll see whether those two cases are different or those two cases can be handled by single code. We'll see that, but let's find out what we need to do here. So in case 1, what we do is, if our start is already null, then whatever node we insert, that will be the first node, that will be the last node. Now first node previous pointer will be null, then last node next pointer will be null. So new node previous and new node next both are going to be null. And then at the end we update our start also, right? We need to update start. Well, in first case, what we have come up with is we say that, okay, n points to previous is gonna be null, n points to next is also gonna be null, and we are going to update our start with new node n. So this is the case 1. If your start is already null, then you'll perform this thing. Okay, now let's focus on the second case. What is in the else part? In the second case, have a look at the diagram now. Your new node is gonna be the first node. The first node का previous pointer null रहेगा. Okay. Then that newly created first node will point to the second node, which is the existing start. Right? Then we need to update this existing first node previous pointer, which was already null. Now it should point to the new node. Okay. And then at the end, we will update our start. We'll update our start. So totally there are 4 pointers we are updating. Now in a doubly linked list, always go for the new node pointers first, right? Always go for it first. So what you do is n points to prev previous and n points to next. You always update these two first because it is not going to affect any of the existing value. So without any problem, we can go for new node pointers. Then we need to take care which pointer we should update. Now before we update start, we need existing start, so we'll do that first. Start points to previous. That was the existing start node, and we need to update its previous first. Now once we are done with all other pointers, we can update our start at the end. So this is the sequence you should be careful. Now we can simply say, okay, new node previous should become null, new node next should become the existing start, then start node previous should point to the new node n, and then we can update our start with new node n. So these are the 4 statements we need to take care. right? Now from this one, you can say these three statements are equal actually. If you want to take those three statements common from if and else, you can do that. You'll have one doubt. Okay, not all three, but these two statements are common. But yeah, but here also we can say that all three statements are common, because here start is already null, and here start is having something, so still it is that statement is common. So these three statements are common. If you want to take those statements common, then you can. You just need to be careful of this statement only, where start is not null, then start previous new node. We can do that. But this is somewhat basic code of insert first. So let's have a look at the algorithm here. If avail is null, we can say overflow, we don't have enough memory. But if it is not the case, then we'll take a new node from avail. And then what we do is we go for the new node data. We store that data. Then first we update a new node pointer. So new node previous always gonna be null. New node next, in your case 1, it's going to be null, and in your case 2, it's gonna be start. Now in both the cases, start can handle your code, so we are writing that only one line. New node next equals to start. Then start previous gonna be the new node, but here you need to have if condition. If your start is already null, then you cannot have its previous, right? And then at the end you update your start and return your start. So this is the insert first algorithm in a doubly linked list. If you are clear with singly linked list how to maintain next pointers, then here additional one pointer previous is added. So just like you maintain your next pointer, you just need to maintain previous also, and that will give you the doubly linked list, right? So let's have a look at the next algorithm also, insert last. We'll understand insert last, and then we'll have any question if you have. So in insert last, again we may have two cases: empty linked list and having some nodes. If your linked list is empty, then your start will be null, and if it has some nodes, then your start will be pointing to some node, and you will have the linked list like this way. Now we want to insert a new node at end. So in both the cases we require new node. So let us take new node n, and then we store data given value in the new node also. So if user says wants to insert 6, then let us n points to data equals to n well, so we store 6 also. Till that time I believe no one will have any question. But now let us go and maintain the pointers. In case 1, it's the only node that we are inserting, so that's going to be the first, that's going to be the last, and we need to update start. Now here this case we need to take care separately. If your start is already null, then you need to take care of that thing. Your next new node next pointer should be null. New node previous pointer should be also null, and you update your start. Okay, that's your first case. In the other case, else part, what we should do is, now this new node is going to be the last node, so its next pointer should become null. Then existing last node next pointer we need to update, and new node previous pointer we should update. So there are 3 updates we need to take care. Now, as I said, always go for new node pointers first. So you can say that, okay, in the else part, n points to next, n points to pre, I should update, and then the last node next pointer. But how do we have a last node? Now, before we go for the last node, so if we want to have a last node address, then actually we need to traverse our linked list. So we need to start with tr, and we should reach up to the last node. So for that, we already know how to reach at a last node in singly linked list, and this is no other process. This is the same process. You initialize your tr with start, and then go for a while loop. While tr next is not equals to null, you update your tr equals to tr points to next. Because if I want to traverse in a forward direction, then I need not to be bother of what is previous. I just go forward, and forward link I can have from the next pointer. So same traversal process. Now if traversal process is same, then you can say display process will also be same, no change, right? So with this traversal, we have our tr pointing to the last node, right? So if tr is pointing to the last node, then after that, this entire thing will be in the else part, traversal, then update. Your tr is at a last node, and here you complete. So last node next pointer we want to update. Have a look at here in the diagram. The first thing you want to update is this one, and then there are 2 pointers. So new node next, now it's the last node, so its next pointer is gonna be null always. New node previous pointer should point to the existing last node, which is tr, and existing last node, which is tr, its next pointer should point to the new node n. So that's what we have written here, and that's the InsertLast process, right? So let's have a look at the algorithm now. If your avail is null, overflow, otherwise you can take a new node from avail and store your data. Now this much part is going to be same for each and every algorithm. Now once you have your new node, whether your linked list is empty or it has some data, whatever node, newly created node is, it's gonna be inserted at the end. अगर वो last में insert होता है तो उसका next pointer always null रहेगा. So we take that common part. So next pointer is gonna be null always. Then we take care of 2 different cases. If start is already null, then it's kind of a insert first. So new node previous will be null, and we should update our start and return. Otherwise, we need to traverse. So take ptr, and ptr next is not null. Till that time, you traverse your linked list. Once you end up with the traversal process, that ptr is the existing last node. Its next pointer should be new node, and whatever your new node is, its previous pointer should point to ptr, right? And then we return. So this is the insert last operation also. We have seen insert first and insert last. Now I'll pause here, and I'll again give you time to read these algorithms, go for insert last first. अब यहाँ पे insert last पहले देख लो आप. Read this algorithm, and if you have any doubt, you can ask me. After some time, we'll go for insert first algorithm and you can read it. Try to understand each and every line carefully. And one more thing, you have to practice these linked list algorithms, because the more you practice, the more you will be comfortable with working with these linked lists, whether it is singly, doubly, or any circular linked list, right? So make sure that you are going to practice these processes. Never mug up these algorithms. Always draw this way. Always you go and draw your linked list and then try to understand what should happen when you perform this operation. What should happen if you insert a new node at the end? What should happen if you insert a new node at given position? What should happen if you go and insert new node before or after some given value, and so on? So you draw your linked list, try to understand what should happen, and then you try to write the pseudocode or a program code to perform those operations. So this was insert last. If you want to have insert first, then this is what it is. If you have any query or question, please ask. Okay, so let's move on and have a look at the third operation, insert at a given position. The user will give you the position and a value, and at that place you should insert that value. Now here, if given position is 1, okay, if given position is equals to 1, then it's a special case because it is kind of insert first. Right? It's kind of insert first operation, where we need to update start. This is a place where we should update our start pointer. So we need to take care this case we need to take care separately. Otherwise, when position is not equals to 1, then we should traverse up to that position. Now while we are traversing and we are going to that position, before we reach to that position, if our linked list ends, then we can say invalid position. And if we reach up to that place properly, then we can insert a new node there, right? So for this example, let's say user wants to insert a new value at position 3, and then the new value is, let's say, 9. At third position, user wants to insert 9. And let us have one example here. For example, we have our start pointing to some node, and we have our linked list, doubly linked list actually, like this way. So for example, you have this doubly linked list. Now user will always count the position from 1. So first node is at position 1, 2, 3, and 4. These are the positions. And if user wants to insert a new node at third position, right, then actually when we insert a new node here, then existing node at that place is gonna be pushed afterward. So all these nodes will be pushed in a position, they are going to be pushed afterward. But as long as we are working with addresses, we will simply update these 2 pointers. We will simply update those pointers. We are not actually going to shift any memory location, any value in the memory, right? So what we do is we create a new node, we store that data in a new node, whatever user wants to store, and then what we do is at position number 3 and at position number 2, these 2 pointers we should update. Both those pointers should be pointing to the new node, and the new node previous and next should also be updated. So whatever whatever older path we were having, right, in a continuous manner, now we have via path. So now if we are going for via path, then the new positions will be 1, 2, 3 will be this new node, 4 and 5, right? So that's how we can insert a new node. Now it means if we want to insert a new node at third position, then definitely we need to traverse up to that place. So let's say we start with TR and we go and update our TR. So at the end, your TR is pointing to the third place. Now if your TR is at third place, then the new node that you want to insert is before TR, correct? Before TR, before 3, you want to insert a new node. So if you reach up to that place, then before that node you should insert. And if you reach up to 2, the given position -1, then wherever you have your TR, after that TR you should insert your new node. So that depends, आपको जो भी सही लगता है, जो whatever process you feel is comfortable, you are comfortable, you can do that. Now, I'll be comfortable with inserting after. Then what I'll do is मैं tr को position -1 तक लेके जाऊंगा. Given position is 3, then I'll take my tr up to 2. So that's where my tr is, and let's say now let us insert and let us do that process. So once we have our new node, we can store our data and well, so we store that value 9. Now always go for updating new node pointers first, previous and next, ये दोनों को update करो. So your new node previous pointer should point to tr because we have our tr at second node, and new node next should point to the third node, existing third node, और वो आपको मिलेगा tr के next से, right? So you do that. Now third node, existing third node जो है उसका previous हमें update करना है. Now how can we have that existing third node? We can have it using tr points to next. ये हमें existing third node देगा. Now in a chain, once we have that third node, we will access its previous. And that's what we are going to update with new node n. Try to understand this thing. tr points to next will give you the third node. Now once you have a third node, you access its previous pointer and you update it. Now here is one catch. If tr points to next is not equals to null, okay, if that is not null, then and then only you will be doing this thing. And once we update that pointer, let us update our tr next itself. Tr points to next equals to new node n. So what is the sequence? We have gone for n points to previous first. So here in the diagram, this pointer we have updated first. Then n points to next. This is the second update we have gone through. Then the third node previous pointer we have updated at a third place. And at a fourth place, we have updated tr points to next. Now tr points to next, we keep it at till end because everywhere we are using tr. So we'll update our tr at the end. So these are the 4 pointers we should update, and you have that diagram on the left. So carefully look at this diagram, understand this process. If you have any query, please ask. Now, before you reach up to your position, if your tr becomes null, then we can say invalid position. Whatever position user has given, that's not valid. We are not able to traverse our linked list up to that place. So if this is the process, let's have a look at the algorithm here. And this is the algorithm for inserting a new node at a given position. So if avail is null, overflow, otherwise we take a new node from avail and we store our data. That's our common process for every insert operation. Now once we are done with that much part, we take care of our different cases. So if position is 1, okay, that's the first case, then it is kind of insert first operation. New node next should point to the existing start node previous should point to the new node, and then we should update our start. Now definitely new node previous should be null here. That's still remaining, so we can say n points to pre should be null in this case, and then you return. If that's not the case, then what you do is you are going to traverse your linked list based on a given position, so we need to have a counter. Now once we point PTR to the start node, that is the first position, so CNT is also 1, counter is also 1, and then based on the counter we are going to traverse. So we traverse up to given position -1 up to that place, and at the same time your PTR should not be null, remember. Now while you are traversing, update your PTR and update your counter plus, right? Once you are done with this traversal process, you will check your PTR. If PTR becomes null, you say invalid position. Now if PTR is not null, then that means you have reached up to the place where actually you want to insert a new node. Then what we do is we update our new node pointers first. So new node previous is PTR, new node next is PTR next. Now after that, PTR next gives you the next node. उसका previous जो है हमें update करना है with new node. And then at the end, the last place, we will update our PTR next, pointing to new node n. So that's the process of inserting a new node at place, and we return at the end. So going back to previous slide, and you should read this one. Take a screenshot if you want, because you'll need these algorithms in the lab session when you are going for implementing this part. So this is the half of the part. Let me navigate to the next part in a slide. So now you can have a look at the remaining part. Don't forget to have if condition here. PTR next is not null. If PTR next is not null, then and then only you can have a previous pointer for that node. Don't hesitate to ask your queries. This is the best time you can ask anything that you have a doubt. Fine. So that was insert at a given position in a doubly linked list. Let's have a look at the next operation now is insert before. Now, kind of insert after operation we have already seen in this insert at position, because we have traversed our linked list up to the position -1, and we have inserted a new node after that. So insert after process we have already done, but how can we do insert before process? So let's have a look at it. Now we are going for insert before. Now before and after, both these operations are based on the existing value. The user will give you the existing value and a new value, and before the existing value you want to insert the new value. That's what the process we want to do. So one existing value will be given to you. Now what if that existing value is there in the start node itself? Okay, if you find that existing value given by user in the start node itself, then it's nothing but the insert first. Right, that's the insert first case. So we've already seen how we can insert a new node at first place. We can go for that process here. Now if that is not the case, then in the second case we should traverse our entire linked list and we should search that existing value. Okay, in the second case we need to search that existing value. While we are traversing and searching that existing value, if your TR becomes null, that means you are at the end of your linked list and still you don't found that value. So we can have a message value not found. But somewhere in between, if you found that value, then you stop your traversal process. And once you stop at that place, before that place, you need to insert a new node. That's what the process is, this one. So let's say we have a existing linked list here. Right, we have an existing linked list here, and user says you insert a new value, let's say 8 before 6. For example, let's say user gives this thing. So where do you find your 6? At this place. And before that 6 means at this, before, so in between 4 and 6, you need to insert a new node. That's what you should perform here. Now if you want to do that, first we need to traverse. So let us have a look at the traversal process. We start our TR with start, the first node, and then we are going to traverse it until TR points to data is not equals to existing value, and at the same time your TR should not be null. We will update our TR in a forward direction. TR equals to TR points to next. That's it. Now when you are done with this while loop, you should check if your TR is null, then you can print a value, print a message, value not found, because before you have a value, your linked list ends. Now in the else part, we can say we found our place. Then actually you have started from the first node. Have a look at the diagram. You update your TR and you update your TR. Now when your TR reach up to the node which is having existing value, you'll stop. So your TR will be pointing to node having data 6. We can have a new node, we can store new node data, we have all those things. Now if we want to insert this new node here, then new node next should be TR. New node previous should be the previous node which you can have with TR points to pre. That means new node next equals to TR. New node previous should be TR points to previous. Then the previous node next pointer should be N. So we say here TR points to previous will give you the previous node. Now from that node you update your next pointer equals to N. And the last one, TR points to pre points to N. So that's the last pointer we should update here. And we are done with updating all 4 pointers. So this is the insert before process, right? Let's quickly have a look at the algorithm. Avail is null, then overflow. Otherwise, we take a new node from avail and we store the data. Now, if you find your existing value in the start itself, then this is the process of insert first. Okay, this is insert first process. Otherwise, we start from the first node or second node. Now here you can take your pre-PTR just like we were doing in the singly linked list. So हर बार PTR update करने के साथ साथ pre-PTR लेके जाओ, but actually we don't need to have this one because in a doubly linked list we have a previous pointer. So while you are traversing, your PTR data is not equals to existing value and PTR itself is not null. You are just going to update your PTR. Now if PTR becomes null, value not found. Otherwise what you do is new node next is PTR, new node previous is previous PTR, so that is PTR points to previous, right? Then PTR previous will be new node, and previous node you can have by PTR pre, and then that updated to the new node, and then you return. So that's the insert before. Minor updates here, whatever I have written here in the slide. So if you are comfortable with going through the extra variable pre-PTR and always bringing that previous with the previous with the TR, then you go for it. Otherwise you can have this thing also, right? So this is insert before, but I'll suggest you should go for this process. I'll suggest that instead of having extra variable pre-PTR, you go for this chaining. TR points to pre points to next. Now here we need not to have if condition because TR आगे तभी गया होगा जब उसका previous node होगा. So just like before, हमने जो if condition लिखा था उसकी यहाँ पे जरूरत नहीं है. So that's your insert before. We'll stop here. So today we have seen what is doubly linked list, then insert first, insert last, insert at position, and insert before. These 4 insert operations we have seen today. Insert after is almost covered. Insert at position में हमने जो link update की, that was insert after operation. So I suggest that before you come to next lecture, you try that out. Insert after आप खुद try करके लिखोगे. Write a pseudocode for that. Now in the next lecture, I'll show you how insert after will be performed, and I'll show you the pseudocode so that you can compare your code with that, and then we will move on. So that's it for today. Thank you for joining this session. See you in the next one. Thank you. You may leave now. If you have any question, ask. Otherwise, we are done here.